Assalamualaikum and hi everyone. Today I want to share a sample calculation involving redox titration. So here is the sample question. A 0.47 gram alloy sample containing tin is dissolved in sulfuric acid to produce tin 2 ion. This solution is diluted to the mark in a 100 ml volumetric flask. 325 ml liquids of this solution is titrated against 0.0107 molar solution of KMnO4, forming tin 4 and manganese 2 ions. For question A, determine the oxidation state of manganese in KMnO4. So, oxidation state here means oxidation number. So here is the sample calculation of oxidation state of manganese. Right, so as the KNO4 is a compound, so the oxidation number of KNO4 is 0. Whereas for potassium is positive 1 and oxygen is negative 2. Okay, so therefore, the oxidation state of manganese is positive 7. So remember, please write the sign before oxidation number. Next, for question B, write a balanced equation for the reaction of MnO4 minus ion with tin 2 in acid solution. So the keyword from the question here is tin 2 ion forming tin 4. And the other one is MnO4 minus ion forming manganese 2 ions. So the first step, what should we do? You can divide the equation into two half equation. Okay, next, we calculate the oxidation number for each species. Right, as the oxidation number of Sn increase from positive 2 to positive 7, so therefore Sn undergoes oxidation. So whereas for Mn, so it reduces from positive 7 to positive 2. So therefore this is reduction equation. For the second step, you have to balance both half equation. Right, so for the first step in balancing, so you have to balance element other than oxygen and hydrogen, which refer to Sn. So it is already balanced. Since there is no oxygen and hydrogen present in the equation, so we can skip step 2 and step 3. Now we move to step 4. Charge, okay, balance charge by adding electron at more positive side. So therefore you have to calculate the charge for each for both side. Okay, so we can clearly see that at the product side it is more positive. Therefore you have to add 2 electron at the product side. Okay, so we calculate again the total charge. So it should be the same. Okay. Alright, so next, same thing goes to the reduction. So first of all, balance element other than oxygen and hydrogen, so which refer to Mn. So it is already balanced. Second step, okay, balance oxygen by adding H2O. Right, so at the right-hand side, there are 4 oxygen. Whereas at the product side, there is no oxygen. So therefore, you have to add 4 H2O. Right, since we add 4 H2O, we already add hydrogen, 8 hydrogen at the product side. And there is no hydrogen at the right hand side. So how that we can balance? So hydrogen by adding H+. How many H+ is referred to the product side? So there are 8 H here at the product side, so we have to add another 8 H+ at the right hand side. And finally, so balance charge by adding electron at more positive side. So we calculate the total charge, 8 times positive 1, positive 8, 1 times negative 1, negative 1. Okay, 1 times positive 2, positive 2, 4 times 0 because it's compound 0. Okay, next we total up the charge. Okay, at the product side, the total charge is positive 2, whereas at the reactant side is positive 7. So we see here that the reactant side is more positive, so we have to add electron at the reactant side. How many? So it should be okay, when we calculate, it should be the same charge as the product side. So we add another 5 electron, okay, at the reactant side. Right, so we try to calculate it again. So finally we notice that both sides, the charge of the both sides is equal. Step number 3. So multiply both equations with an integer to balance the number of electrons. So as we can see here, the oxidation equation, so we have 2 mole electron, whereas for the reduction we have 5 mole electrons, so it's not equal. So therefore the oxidation half equations, so you can times it with 5. Alright, okay. Right, next for the reduction, so can times by 2. Okay, and the equation become like this. So and the number of mole of electron, okay, for both half equation is the same. Step number 4, combine both equation. Okay, so since the electron is at the opposite side, okay, so we can cancel out the number of electron. Okay, and then there is no other same species at opposite side, so we just combine reactant one side and the product one side. Step number 5, so you have to check the total charge of both sides of the equation, means at the reactant side and also the product side. Okay, so we calculate. So 5 times 2 plus, we get positive 10. Okay, 16 times 1, so positive 16. 2 times negative 1, so negative 2. Okay, as for the product side, 2 times 2 plus, so we get positive 4. 8 times 0 equals to 0. 5 times positive 4, so we get positive 20. Next, we total up the charge at the reactant side is positive 24. And as for the product side is positive 24. Right, so this means that the equation is already balanced. We move to question C. If an average titration requires 15.61 ml of MnO4 minus solution, calculate the number of mole of MnO4 minus used in the titration. So already given in the question, the molarity of KMnO4, that is 0.0107 molar. Okay. Right, so first of all, so we have to write the dissociation equation. So in KMnO4, so it has K plus ion and MnO4 minus ion. From this equation, we can clearly see that 1 mole of KMnO4 is equivalent to 1 mole of MnO4 minus. In the question, is already given the molarity of KMnO4, so which means that the molarity of MnO4 minus ion is the same, which is 0.0107 molar. So we have the molarity and we have the volume. So we can use the formula of molarity to calculate the number of mole of MnO4 minus ion. Right, so moles of MnO4 minus ion is equals to molarity times volume. Right, so please remember, molar means that the unit is mole per liter. So therefore, volume should be in liter. So we have to convert from ml to liter. So, and finally, the number of mole of MnO4 minus is 1.6703 times 10 power of negative 4 mole. For question D, calculate the concentration of the SN2 plus solution. Right, so to calculate the concentration, which refer to the molarity, so we need the number of mole of SN2 plus ion. Okay, as in the question is already given the volume of SN2 plus, which is 25 ml. So therefore, in the previous calculation, we already calculate the moles of MnO4 minus, and then we need to find out the mole of SN2 plus. Okay, so you can use this formula, MAVA over MBVB equals to A over B. Right, so calculate the concentration of SN2 plus ion. Right, so MA is referred to the molarity of SN2 plus ion that we want to find out. VA is referred to the volume of SN2 plus, which is already given in the question. MB is referred to the molarity of MnO4 minus, also given in the question. Volume of VB is referred to the volume of MnO4 minus. Okay, already given in the question. Right, so A here is referred to the coefficient of SN2 plus, which refer to 5. And B is referred to the coefficient of MnO4 minus, which refer to 2. Okay, for the next step, so we can substitute all the values. Okay, right, so MA is referred to the concentration of SN2 plus that we want to calculate. So VA is referred to the volume of SN2 plus, 0.025 liter. A is stand for coefficient of SN2 plus, which is 5. And then MB is referred to the molarity of MnO4 minus, 0.0107 molar. And VB is referred to the volume of MnO4 minus, that is 0.01561 liter. So please remember here, volume, okay, should be in liter, since molar is referred to mole per liter. Okay, B is referred to the coefficient of MnO4 minus, that is 2. Okay, so and finally we'll get the concentration of SN2 plus, that is 0.01677 molar, which is referred to the molarity of SN2 plus. For the last question E, determine the percentage of tin in the alloy. Right, in the previous calculation, we already calculate the molarity of SN2 plus, that is 0.01677 molar. And then it's already given to you the volume of the SN2 plus solution, that is 100 ml. So we have molarity and we have volume. So therefore we can find out the mole of SN. Okay, in order to calculate the mass of SN. Okay, alright. So we just substitute in the formula. Okay, so we get the moles of SN2 plus is 1.6703 times 10 power of negative 3 mole. Alright, next, as we know that mole of SN2 plus actually is equal to the mole of SN. Right, next, find out the mass of pure SN, mole times molar mass. Okay, so mass of pure SN is 0.199 gram. Okay, next, you can substitute all the values into the formula. Okay, so we know that in the previous calculation, mass of pure SN is 0.199 gram. As for the mass of impure SN, so in the question is 0.472 gram. Right, so here is the formula. Okay, just substitute. And finally, the percentage of tin in the alloy is 42.16%. Okay, thank you, and we'll see you again in the next class. Bye!